Okay, we are recording. So good morning, everyone, and welcome to this month's USF community meeting in the EMEA and NAMO time. Today we have Sheng who's going to present about Payload Handoff. But before we get started, I was curious, does anybody have any opens? Hearing resounding silence, I will assume no opens. And for those of you who just logged in, I was speaking to Vincent, is going to present about the USF 10 spec at the next regular USF community meeting. Thank you for offering to be here for that, Vincent. And with that, I will go ahead and turn it over to Sheng so that we can see about universal payload.
Yeah, thanks, Mickey and Vincent, for arranging this. Are you able to see my full screen for presenting, or just the just the half?
Yeah, we see the whole slide.
Yep.
Okay, you can see whole slide, right? Cover. Okay, that's good. So yeah, good morning or good afternoon or good evening, everyone. So I'm going to present this. So for the universal approach for payload handoff design. So this has been working together together with Arthur and Zhi Guang since a few months ago. So just a quick history about this, right? So this has been, I believe that Zhi Guang also presented a few months ago about using CBOR as a alternative for payload handoff design for all the different platforms. So, but yeah, I will go through the reasoning again for why we came to this conclusion, and then will be the best approach after months of discussion. So that I also appreciate if you can provide your feedback from your side. Okay, so let's start with the problem statement. There's a UEFI and core boot, the two main bootloader solutions for EDK2. Also includes a symbol as well, which is also using the hop. And so these are the two main handoff design that has been used by different solutions. For UEFI, is using hop. So I'm sure all of you are quite familiar with the hop and design. It's container fields specific for EDK2 DXC, and then unfortunately, it has a 64K limit because it's a 2-byte size entry. And this is a personal preference. Like some people doesn't like the 16-byte GUID instead of the tag number, right? So these are the kind of thing that prevent hop to be more generic to all the bootloader solution. And then for the core boot table, of course, you can know it's very old. It's been more than 10 years old, and then it's using the kind of the tag you can see from that. And then the payload have the data and then cannot be probed directly from the hardware itself. And then it's also because it's a GPL license, so that's why it's very hard to be port everywhere. And how we end up to this initiative is because we want to find a solution, a handoff that can be generic and can be self-describing, but both EDK2 hop and also core boot tables doesn't fit in this two scenario. Yeah, I'll go to the next slide. So the solutions, right, is easy. Either use core boot tables, or use hop, or we can also invent a new standard that overcome the limitation for hop and core boot table, which is how we came up to here today. But here, ask back the original question: what would be the expectation for a proper universal handoff design? A universal terms in here means that it can be applicable to all the bootloader solutions, like for example EDK2, U-boot, core boot, or Linux boot, and other boot solutions as well. And the first thing that we ask is for self-describing. So it means that when the information passed from one stage to the other stage, it can be easily understandable, and then you can tell from the data itself that it can easily identify. You do not need any decoding, special decoding parameters to decode all of them. But with this self-describing format, you can be easily understand from the both side. So it's a very key criteria to pass the information between two stages, between the bootloader and the payload. So the second thing is also very important. We would want a solution that is not bounded by any single language. So for example, we do not want something that is only work on C, and then you have to rewrite everything in Rust, or can only work in Rust, and or any special language. And also the data has to contain all the information that payloads required here, which is obvious, like memory map, built-time information, and then UART, and also frame buffer, all these kind of standard things that the payload required to initialize properly, so it can be initialize the OS as intended. And then the fourth thing is that we would want a solution that can be a smooth transition for all different payload projects. And then, which is a lightweight introduction. This is why initially we thought that CBOR is a good idea, thanks to the great work done by Zhiguang. But however, the later we found that CBOR has a huge introduction cost for all different payload, because the library is not there for each payload. But compared to the one which I'm going to introduce today, which is FDT, Flattened Device Tree, I will go on later. I can show you that how it is being shown to be easier to be integrated in all the boot solution. But here, other than just now we talked about the expectation, right? We also want to think about the future scope of this. So broader scope. Are we only doing this for the payload itself? Because payload is also the thing we want to resolve. So that can be also applicable to other binary interfaces, for example, in the FSP, which I also describe it later. And then I will show you how simple it is and how it can be justified by extending this to FSP, that it can help the customer to use the interface. Because despite a lot of noises, FSP is still a great invention in the way that help people to load Intel platform, integrate Intel platform in a very easier manner. This is also not an x86 specific issue and has been already resolved, like what I mentioned before. So we do not want to reinvent the wheel with heavy introduction costs. So here we go. We landed in the flattened device tree after several discussion. The spec is already out there, and the library, which is really, really important here, like I said, we don't need to reinvent the wheel. The library, FDT library, has already existing in the EDK2, core boot, and so U-boot, and Linux boot as well. And so that in a way that we do not need to persuade the community to have to introduce a whole new a big chunk of code just to support the handoff data block. So this is a good I think for the community, and then also for the integration, because we finally have a universal standard that can be easily incorporated in all the different boot solutions. And then it can also easily describe the hardware and path control. And the libraries is, like I said before, available in a lot of different languages. And it's a binary and plain text format. Later I will show you how it's binary things work. So you can see here, for example, if you want to pass, because you need in the payload, you need to pass the memory details to the payload itself, right? And then so in this way, you can see how easily the way format it is. So just memory, device tree, memory, and then the register. So it's a very neat and clean format in a way that is easily understandable, and it's just so easily to be passed to each other. Yeah. So the POC. So these are the POC that. Feel free to interrupt me if you have any question about this. Yeah, then we can.
Are there any alignment requirements? Like it has to be on a D-word boundary or anything, or it can be starting at any address offset, like the base of the FTT structure.
Oh, okay, that's a pretty good question. I'll get back to you on this. I will take the AI and get back to you on this. Is that okay?
Okay, sure.
Yeah, thanks. So the POC for this one has been done. So the flow, as you can see from here, I will just, yeah. So the build time creation of the structure, unpack it during the boot time, apply fix out on the nodes. If you are familiar with FTT4, you understand the nodes itself, like there's a different, or you can attach all different nodes to the FTT. Pack it again, pass a pointer to the payload, and then payload passes device tree using existing library, or they can pass this device tree natively if they want. And so as I mentioned, I do not want to reinvent the view. So the field definition required for FTT, which is like what is expected for the payload, right? So Zhiguang has done a great work on there. He has put at a CBOR in the USF. So we will just kind of reuse that because he has clearly defined what is needed there. And all this work is for the FTT is not actually is done by our engineer Arthur, which is a really smart engineer. So he has done all the work. For the patches, you can look at the link here, how it's being done for the corpus side and how it's being done for the EDK to fetch data. So these are the two links that you can refer to. Yeah. Okay. So back to the question just now, right? We talked about the other use cases for the FSP. So because this is a USF forum, so I think this is appropriate for me to also mention the FSP in this scope as well. So for example, you can see that the FXP, currently the UPD, it is usable, but it can be further improved for the much better experience. For the first thing is that it's not very flexible because every time when the new FSP version for each specific platform, right? When you introduce like let's say from MR1 to MR2, that maybe you might introduce a new field in a way. But when you introduce a new field, then you have to integrate the latest header, or else there will be a header mismatch and it will fail in the building. So it's not very flexible in this way. The second thing is not scalable. So it's a one struct for all the IPs and configurations. So you have a whole chunk of FSPS file. And then there's no, it's very, in a way, it's very hard to navigate with, if you are a customer, right? You want to see, okay, if I want to go to UART, where should I go? If I want to go to the graphic setting, where should I go? So there's no, not in a way, not very scalable in a way that it categorize or separate the FSP configurations in a very clean way. So it's not scalable in this way. And it's not reusable at all. So every time when you have a new platform or you have a new platform, you have to introduce a whole new the UPD, and you can't just, in a way, when you have a scalable, then you can make it much more reusable in a way that, okay, this field is generic for all these tangent or above platform, so you can make it in a more clean way. Yeah, so you can, I think by saying this, I think all of you are quite easy to understand how this can be usage. So I can show you a pretty usage. So you can see, for example, this is from the user side, from the bootloader side. If the FSP is in the FTT way, so you can see it can be coding, it can pass information in a very clean way. So you can see package, profile, memory down, and then the information. It is much more cleaner, especially for me, who has been doing the 5 years to integrate the FSP parameters for all the different platforms since Kaby Lake. And every time you port a new platform, and then you have to find where the parameter is, and then you have to find where to insert it, how to categorize it. But in this way, it is very, really neat, as you can see. Yeah.
And
So,
this is this like this is a text variant, but in the actual binary, like what the bootloader passes, is there a binary encoded version, or is this kind of encoded in ASCII text that you could actually parse the ROM and see, or is this just there's a binary version of it that's actually in the ROM? What does it look like in the flash? Like this data structure, I guess. Can you actually parse it and
I believe the answer is yes, because I think I discussed before that you can actually parse it. But I will also get back to you on this.
I think on here is what's called the source of the device tree. So there's a format called DTS, which is human readable. It's all ASCII. And then you can compile this to, so to speak, and generate a binary format which is more compressed. And it's not entirely ASCII. It's not, the information is not represented with ASCII characters. Now the question is, Vincent, whether or not the level of compression that this binary format has. Not entirely sure what.
Gotcha. Oh, so this is the DTS format. Okay, gotcha. And then there's now I remember, yeah, to like build U-boot, I have to install the DTC compiler.
Yeah.
So it goes from DTS to a DTB, right? Isn't that what they call the binary? Like
Yeah,
if
yeah.
okay, like my RISC-V, the F540 has a DTB that the second stage loader. Gotcha. Okay, and so yeah, the thing I guess I'd have to poke at is some of this still, are there still ASCII artifacts in the ROM, or does it all go to a binary? Or gotcha, but this is the DTS, and this DTS is different than the core boot DTS they have for building the chipset code, correct? Because that's another kind of weird confusion that the core boot community has. The device tree when they build their RAM stage chipset state machine, right? That's different than this one, I believe, correct? It's not the same literal DTS, right?
No, that is a different DTS.
Okay.
The device tree, yeah.
Gotcha. Okay, gotcha. Yeah, thanks. Yeah, that should have, I think it's the 7 a.m. morning here. You're right. The DTS versus DTB. Gotcha. Okay, thanks.
Yeah, I believe that was Jose, because I can't see the screen. So,
Yes, Sheng. Yeah, it's just.
yeah, thanks. Yeah, thanks for jumping in and help. Yeah, really appreciate it. And okay, yeah. So other than this, so here the timeline. So you can see that this is a timeline that had been started, the effort from March. We have initiated, yeah, you can see March is an initial discussion with all the committee members, and April we have a meeting, and then we kind of exploring CBOR and then discuss collecting feedback how it can be done, and then how is when we measure it, how is the introduction, and how will each committee accept it. But then we landed. We take few months to explore it. Then we landed in the July. Then we think that FTT is a better solution that has a lighter introduction cost for all the platform. And in August, as if you attend the meeting, there's a consensus reached between the key contributors from the EDK2 and then also from the corporate side, and also that the committees will proceed with these. So in the September, we also presented in the OSFC for the broader feedback, and thankfully we get the blessings from the UBoot with Simon Glass, and also from the corporate community that we should actually go ahead and do this. So now we are we are drafting the specification for feedback. So I believe that in the November we can have the initial spec for the broader feedback, and then the code patches has been submitted to the core boot already for now, the work in progress, but it will be land on the EDK2 and the Linux boot as well together. And December 22 is we finalize the handoff spec, which is aligned to the USF timeline. Any question on this? Okay. Yeah. So I think the conclusion is here, that we are doing the open development instead of just open source. So open development means that we engage everyone from the community and then from the industry early head on to tell them what we are expecting and what we want to do, and can get the feedback. Of course, this will take a much longer time and process, and then there will be a few pushback that's expected. But in the end, if everyone accept it, it will be acceptable, of course, adapt for all the bootloader solution. And the second thing we see that is we finally, after so long, we see the cross communities collaboration. And I really appreciate for all these people from Intel EDK2, and then also from the core boot and also from the ARM. They are all the good willing people, and they all provided a good gesture of trust for us to push this together, because this is really hard to find a common ground when every bootloader has their own expectation in a way. So now we have a common ground, at least between all U-boot, EDK2, core boot, and also same bootloader. And then this is actually an initiative that we can finally claim it is by the community and for the community. And this is only the beginning. So this is only the first showcase that actually different bootloader solutions can come together and work on for the greater good. And then in the future, when we want to push for something, because the firmware itself, the initial principle and philosophy is we just want to make it work for the platform and let it work smoothly on the OS. So in this line of thought, of course, the more simplified it can be, the better. So that's why it makes sense to make it universal for all. So, and also we also found a very lightweight industrial-wide solution with a small integration fees I mentioned before. It's really reusable and adaptable for other like FSP, and it's self-describing as mentioned. Okay. And so special thanks to all these key contributors from Intel side. Then we have from Intel, from ARM, and then from Google, Siemens, AMD, and also 9elements. Yeah. So that's all. Thanks for everyone. And this is just the beginning, and then there's still a lot of work to be done, like drafting a spec. And I will share the documents once the initial spec has been drafted. Hopefully by end of this month. Then we can slowly push forward to reach the final spec by end of this year. Yeah, that's it.
And this is great. And when you said on the prior slide, like small integration fees, it's not like a literal cost. You mean I'm guessing you mean small integration overhead or effort.
Yes, that's correct.
Okay. Yeah, we don't like have to pay device treater or some money or anything. Okay, good.
Yeah.
Okay.
That's what
cool.
I mean. Like you don't want to reintroduce a library, because if you introduce a new CBOR library, you introduce a whole chunk of code itself, and then you have
it's responsive to your point earlier about we'd have to do a big uplift in the industry and teach everyone CBOR and upstream a bunch of libraries, and gotcha. And then maybe the size might impact folks in the early stage bootloaders. Okay, no, that point makes a lot of sense. I'm just curious. I know since we're only talking like the low level interfaces, the platform init, early platform init from late platform init, we're not talking about the use of device tree as the OS handoff. But
Nope.
for that, for that, I've heard in the past, one of the claims is when you do device tree for like Linux, you have to have like the DTS files in the Linux kernel and build the DTBs there. So you sort of have to have DTS on both sides, the bootloader side and the kernel. But I never quite understood the history of that. If it's self-describing, why, and maybe this is, we don't have Linux kernel people here, but I'm curious why Linux kernel had to carry DTS source, and if we would fall prey to that challenge of, you know, the producer and consumer of the DTB would both have to be rebuilt with DTS. And is any, you have any insight into the Linux? It's a complaint I've heard that the ACPI guys have levied against it. Have you heard any, I guess, have any insight on that and whether that's a material concern for the firmware usage?
I don't have answer to that, but I do have the answer to your first question. As you mentioned, the scope is only between the payload and the firmware itself, and I mean the bootloader. So we will define also in the spec that we also pass the ACPI pointer, which is expected from the payload, and whether how the payload wants to either use a FTT or want to use ACPI. That's depend on the payload to decide, right? So we are not going to how to say discuss or define on that. So this is clearly just a boundary between the payload and the bootloader. That's it.
Okay, yeah, that makes sense. And I'm guessing, what we try to do with the USF's part of UPL is say, what are the subset of required objects? And even though we defined them in Hobbes, so you could get the interoperability by saying the producer and consumer should at least support this subset. So maybe that's how we could handle the, having to rebuild arbitrary sets of DTS. Like the kernel problem, I suspect, is people do crazy things in the kernel. But for this low level boot, we could probably come up with a subset of, Hobbes or FTT entries to describe resources like memory, IO, like you mentioned UARTs, because the world is much more constrained from early bootloader to later bootloader. So, okay. And do you have any experience working with devicetree.org as a community? Like, are they pretty open to adding new types? I went to their website and it looks like it's, a spec is on GitHub and there's a mailing list. Anyone on the phone have any experience working with that community? Are they pretty open-minded and flexible and responsive?
So I don't have direct experience with working with device tree, as in contributing device tree bindings to the device tree people. But Rob Herring is the device tree maintainer and is involved with this community. And
Oh,
yes,
nice. Okay, so he's a maintainer. Nice. Okay.
And to answer your question, I was told that the device tree is pretty open and welcoming of contributions.
Awesome. Yeah, I mean, I think that's kind of, to me, what's key is, being able to, have everyone just, be very transparent. One of the things we realized with like the UEFI forum, we have the UEFI spec, which is often driven by the OS vendors when they want stuff, the shrink wrap guys. PI world is, it's very much driven by implementation, often community. You'll notice we don't produce a PI spec very often. So yeah, I think it's a great testament having all these different communities reading in on this effort, having a community-based approach to build the data objects, not being constrained by a more formal, heavy spec process, since these bootloaders are sort of born in the open, live in the open. having a community to manage the namespace sounds pretty appealing at first blush. So yeah, your other feedback on, I think, the FSP, I think this is the right form, and I think it makes a lot of sense given we're very, um, the complexity that cost you mentioned is everywhere. Size, training people. So if we were to do FTT for UPL input, it makes sense to explore FTT for UPDs because of, the issue you mentioned today with UPD maintenance. And then the other part of FSP I was going to ask you is the handoff from FSP is Hobbs today. I'm guessing it's almost implicit that your advocacy for FSP would be to use FTT as the handoff of FSP so the FSP could directly connect to a payload, for example. Is that a fair statement, Li Sheng, or am I putting words in your mouth on that point?
I mean, yeah, I think that could be one way to explore it if you want to simplify, but I can't speak for the FSP team. Yeah. Yes, but I think that could be also one way for them to explore if it makes sense for the simplicity and then for the better communication. So yeah, why not? Just we can use that as well.
I see. So that wasn't like a discussion that surfaced as OSFC or anywhere, but at first blush it seems logical, but it hasn't been peeled open yet. Okay. Yeah, I'm just wondering if that's going to be the challenge since we already have Hobbs in the PI spec and a lot of practice with Hobbs. It could even be an evolutionary approach, I guess, of Hobbs, and then the platform code could convert to FTT to invoke payloads, or FSPs could grow into be FTT native, both on configuration and output, but those are kind of could be on separate trajectories or something. Okay.
Yeah, we can also start with the communication layer, which is the API, like the replacing the FTT. Replacing the UPD with FTT first. Then later on the FSP can change the communication between FSP and the bootloader via the FTT. That could be the next step.
Gotcha. No, and it's very timely too, because even within Intel, we have dispatch mode with policy, PPIs, UPDs for API mode, and there's no customer value being different. So yeah, I think this is a potential opportunity to help clean that up. And as they sometimes say with architecture design changes, disadvantaging both sides a little bit, right? Making everyone have to change a little. So having
Oh, okay. I see where you're looking at. Okay, that makes
so
sense.
I think
Yeah.
it's a good point, and we definitely want to make things easier for customers. No, I think that's a great input on the FSP looking at FTT. So FTT has the community. There's the upstream compilers going from DTS to device tree binaries. People don't have to ship device tree source. They can just ship binaries since it's self-describing. They can read a spec. So no, it seems pretty provocative. And then I guess integrity, is it up to the consumers and producers? So there's like a checksum or something they run to make sure you have a good DTB, or is that kind of out of scope of device tree? Do you know if that's something people worry about? Like if I get a DTB binary in memory, do I know it's a good one or not? Or do they just assume, since this is all construction elements? Like I guess ACPI does checksums. I'm guessing there's probably something like that that device tree has to do basic integrity checking, but I probably should read the spec closer to dig that out myself. But okay. And then I guess the EDK2 community has FTT already because the was that a lot of that driven by ARM because some folks boot EFI with FTT still, even for the OS boot. So is that why
Yes.
there's okay?
Yes. That's why I think that's what other found from that side. from the package.
Gotcha. So it's got a spec, it's community owned, it has producer and consumer code of all the bootloaders. Nice. Okay. Yeah, and I guess the other question or thought is, when we were evaluating Hob versus Seaboard, we sort of put, in the spec, the USF spec, since we didn't really have community consensus on moving to Seaboard, we sort of documented as an alternative. Were you thinking on this FTT handoff spec? Were you gonna write a separate spec, contribute maybe a pull request to the USF spec? What were you thinking for this next month's activity on how to evolve the specification? Like, was there any discussion in OSFC or on the core boot dev list around how to manage this information?
Yeah, wait, can you see my screen? Someone just called me and I got interrupted.
Oh yeah, I can see your screen. Yep, yep.
Uh, okay, never mind, it's not showing up on my side. Okay. So how we're going to approach this is we're going to put so now we got the feedback from ARM, Intel, and also other community. So I'll put all the feedback and draft the spec into the Google Doc, and then share to everyone for review and then to add and stuff. Then later on, then we can publish it. Is that what you're asking for?
Oh, so you're thinking just publish it as a Google Doc, and that's how to manage it over its lifetime, or is that the long
No,
term?
that's just for the draft review to publish.
Gotcha. So people can put comments and stuff. Gotcha.
Yeah,
Okay.
yeah.
No, that makes a lot of sense. Yeah, Google Docs are really great for collaboration and tracking. Much more lightweight than having to, do it in an MD file or something. Okay.
Well, thank you, Sheng, for coming and presenting today. I really appreciate it. I know we've had a hard time getting you here.
Yeah, I wish Arthur could be here as well. Unfortunately, couldn't make it because he's also the technical person behind also pushing for this as well. And I also take a few ARs. I will send out the email to once I got the answer.
No, I think this is awesome. Yeah, it seems like it's the Goldilocks, solution, right? Hubs were clunky. What a Goldilocks? The porridge, right? The hobs are too cold. Seaboard is too hot. FTT is just the right temperature of the porridge. So yeah. I think it's good to see the community kind of converge on that point. So
Vincent, you have a very nice way to describe things.
I need simple stories to keep track of stuff in my head sometimes. So yeah. No, and I think this deck is great. Yeah, because I was looking at your OSFC page and I just saw the YouTube and I was looking for your presentation. So yeah, if it's possible to, if we could post your material on the USF website, that'd be awesome. Because yeah, unless I attend meetings real time, I rarely go back and watch YouTubes, but I always grab people's PDFs of their presentations and motor through them and chase the GitHub link. So yeah, I think it's really a nice deck you presented this morning too. So thanks for doing that.
Oh, thanks for your side as well, because without you, Jose, and the people from it cannot be done until this far. It is a long process. It has been one, but yeah, if there's no persistence from all the parties, it will never work. Yeah. So let's hope we can drive this to the finish line by end of this year. That's what I really hope for.
No, it's awesome, man. No, this is great.
Okay. Well, does anybody have any more questions or anything else that they want to discuss?
Yeah, so I just want to ask the floor if you also have any concern from FTT, or do you see potential concerns that we could address as well, that when we are pushing for this. For the
I
FTP
think the key
solution.
is, yeah, having the various prototype implementations, right? Just to make sure we can do it. But given that there's so much FTT practice in the market,
Mhm.
this is one that, yeah, it seems like the risk meter is much lower from quote implementability. So, yeah, no, I mean, it's rare to have a proposal that, you know, leans so much already on industry practice. So no, I think this is a good thing. And then I know Device Tree started out as an IEEE spec, was it 1275? It's what IBM and Apple did, the CHRP, the Common Hardware Reference Platform. But then it now has become a community thing. So I'm guessing from like the legal aspects have to be clean now because it's community owned. Again, you don't have to sign a EULA or anything to use it. It's there's no encumbrances around it, right? It's not all lawyered up, and so I'm guessing it's given the prevalence of its usage, and given that that shouldn't be a concern, especially now that we're just talking about using it for an internal use case. Yeah, that would be my concern of something that's kind of new from scratch, but I suspect the interop and licensing is no big deal, but I'm not a lawyer and don't play one on TV, but my intuition is it's not an issue, but that's maybe one thing I probably have to ask.
So the licensing for the DTB spec is Apache V2.
Oh, it is? Okay, good. Okay. Yeah, that's
There's some
friendly.
copyright listed for power.org because yes, I think that Device Tree started from IBM when they were attempting to support their power or PC architecture. So the spec does list a couple of copyrights to power.org, Freescale, and IBM.
Okay. Okay, it was just copyright attribution, not a not like, so you have to get a license from them or anything.
Yeah.
Apache covers the legal parts. So it's really Apache V2 vis-a-vis license. No, that's awesome. Yeah, that's what I was figuring, because it wouldn't be so successful in the market if it had something onerous around it. So no, that's awesome. Thanks, Jose, for that. Yeah, it's kind of ironic too that the common part, starting from the chirp, comes back around again. But it's hard to keep a good idea down. So pretty cool.
In terms of determining the integrity of the FTT, I was just quickly going over the FTT definition and the FTT header. I don't think that there is anything like a checksum that you compute over the entire FTT blob, although the FTT header does have a magic number that allows you
Okay.
to determine whether this is an FTT blob or not.
And it doesn't seem to be a problem in practice, because again, I've seen a lot of embedded folks with even shipping DTB binaries, like even out of their boot ROMs, and and given we've always said about like payloads or parts of platform code, it's up to the manufacturer to control the integrity. It's not like we launch RAM stages or payloads or Dixies off the internet, right? So it's within the trust boundary of early platform code to late. And so, yeah, it doesn't seem like integrity, having a fancy integrity story would matter. And even it's impressive that they don't have that and they've used it for OS handoffs even. So, okay, cool. Thanks for that follow up.
Yeah, well, you're not really protected against random bit flips by say some cosmic ray or something. But you inherently assume that the producer of the FTT has done the correct job.
No, that makes sense. And yeah, once we even had a sighting from Rafael. He's now at Apple, but he was at Invisible Things, and he said, "Hey, you have this data structure within SMRAM, and if I can flip a bit, I can break your flow. And I think I even formally replied to his issue that said, if you can flip a bit within an internal data structure of your early boot code, right, loaded out of the flash, you could do a lot more than break this one use case. So yeah, I think that makes sense. It it fits industry practice here, and yeah, I think the trust model is you protect everything in this early phase, including but not limited to data structures within different parts of your platform code. So yeah, that doesn't seem unreasonable in the present state of the art. Okay. This is awesome. Yeah, I think yeah, the upstream tools and practice and a community that's willing to take changes, including a maintainer of this community who's engaged in this effort. Is Rob Herring. That's really nice.
Great information today. So, is there any other discussion? If there's no other discussion, I'm going to stop recording.